Welcome back, Pirates, as we continue to explore exponential expressions. Today we're going to look at our final law, which has us see what happens when you take an expression with exponents and divide it by another expression with exponents. Okay, let's dive right into it and take a look at what we mean by that. Let's look at this expression here. I'm going to ask you, like we've done before, to see if you recognize any relationship between the exponents at the beginning and what you end up with at the end. Okay, so our question is going to be, what is 2 to the 5th divided by 2 to the 3rd? Well, if we expand it out, I know that 2 to the 5th means 2 multiplied by itself 5 times. And 2 to the 3rd means 2 multiplied by itself 3 times. So I'm going to expand that out just so I can see how many 2's are being multiplied. Now, I remember when I was younger that if I had something on the top that was the same as something on the bottom, I could cancel those out. So a 2 on top could cancel with a 2 on the bottom. Another 2 in the numerator can cancel with another 2 in the denominator. Another 2 up here can cancel with another 2 down here. And now I'm left with just 1 on the bottom. And if you notice at the top, we end up with 2 times 2. Or if we want to write it exponentially, we end up with 2 squared. So there it is again. The question of what happens, oh, and look at that, there's 2 of me. What happens with those exponents? So I'll let you think about that for a second before I reveal the next law. Now, if you said, you know what I think happens? I think that when you look at the exponents, they're subtracted. You're absolutely right, okay? Our final law that we're going to look at with exponents says that if I have an expression with a base of a and another expression that's divided with the same base, in this case it says a, you just simply subtract your exponents. So keep the base, subtract your exponents together. So a to the b divided by a to the c is equal to a to the b minus c. So you can see that they just took the exponents and they ended up subtracting them. That's it. So as long as they have the same base, keep that base, subtract the exponents. Now, some people say, you know what? I don't believe you. You're just saying that. Does that always work? Well, I'm going to prove it now. We just did it with numbers. Let's do it with some variables as well. So take a look or consider the following division problem. X to the 5th divided by x squared. Well, according to what we just learned, according to the law, we should end up with an answer of x to the 3rd because we would subtract our exponents. But let's see if this really works when I expand it out. Well, x to the 5th is x times x times x times x times x. Divide that by x squared, which is x times x. We're going to cancel our like those are called factors, those like factors. 2 x's on top, cancel with 2 x's on the bottom, leaving me with x to the 3rd as my final answer. So just like the law told us, we can prove it and we can show it by expanding it out into extended products. Okay? I would expect that that's a good type of test question, to not just apply the law, but be able to also explain it. Okay, well, now that we've seen how it works, and now we know that it does work, let's apply the law to help us investigate a couple of examples here. Okay, here's our first one. 7 to the 9th divided by 7 to the 6th. Okay, so according to the law, as long as the bases are the same, and in this case they're both 7, I keep the base, subtract my exponents. 9 minus 6 is 3. So 7 to the 3rd. All right. Keep going. About negative 5 to the 16th divided by negative 5 to the 7th. Well, if you think that it's negative 5 to the 16 minus 7, you'd be absolutely right. And just make sure when you go to put your answer that you keep that -5 in parentheses. So -5 to the 9th. If you did not put that -5 in parentheses, that would be wrong. That is different, okay? This answer here is different than the one above it. They are not the same. So you cannot put this as your answer. That wouldn't work. Okay, I want to explore two more examples. These ones have a little bit more algebra in them. So this first one says 4x to the third, y to the fifth, and you're dividing that by 2x squared y. Now remember, that's a y to the first. But notice here we have a couple of different bases, and we also have coefficients. So I want to show you how you deal with that. Well, number one, you can just go ahead and divide out your coefficients. 4 divided by 2 is 2. So the first part is taken care of. Divide out your coefficients if you can. Then separate your bases and do them separately. So x to the third divided by x squared is going to give me x, or x to the first. That's what you see happening right here. Then we take our y's and we divide them. Y to the fifth divided by y to the first is y to the fourth. So in the end, we end up with 2x y to the fourth. The 2 coming from the 4 divided by 2. The x coming from x to the third divided by x squared. And the y to the fourth coming from y to the fifth divided by y to the first. So 2x y to the fourth. So basically, we just separated them and looked at them each as a separate division problem. Okay, and finally, last but not least, look at this one here. If you remember from a few lessons ago, we did the distributive property of division, which means if you have a whole polynomial, a whole expression on top, it needs to be divided. Each part gets divided by what's on the bottom. So really, if I wanted to, I could separate this one out and do my distributive property of division. So 12x to the fourth divided by 3x, -6x squared divided by 3x, and positive 9x divided by 3x. The distributive property of division tells me each term on top should get divided by that single term on the bottom. And now I'm just going to apply my exponent laws that I learned today. So for that first one, 12 divided by 3 is 4. X to the fourth divided by x to the first is x to the third. I'm 4 minus 1. Minus, it looks like 2. X to the 2 minus 1 is 1. I'm not even going to put a 1 there. Don't have to. And then if you look here, we have 9 divided by 3 is 3. And x divided by x, well, think of that as those would cancel, and we won't end up with an x in that final term. So 4x to the third minus 2x plus 3, my final answer. So in a case like that, you can just simply make sure that everything gets divided by the 3x, okay? Again, the distributive property division comes into play here. All right, you're going to give your classwork a try and practice some of the things that you learned today. Good luck.